Hi everyone, my name is John Paul CD, Assistant Professor, Department of Mechanical Engineering in Rajgir School of Engineering and Technology. In this video lecture, we will be discussing engineering graphics, especially the topic called development of surfaces. You know what is development? A layout of a complete surface of an object is called development or pattern. The layout of only the sides without the top or bottom surface is called the lateral surface. That means it will look like this end and that end will be missing. So that's, the remaining portion is called the lateral surface. The questions might be like develop the entire surface or develop the lateral surface of a given solid. So you must keep it in mind that if it is lateral surface, you need not develop this surface, the top or the bottom surface. The surface of an object which are opened out and laid on a flat plane are called the development of the surface of that object. So here you can see that I have a prism over here, the development which will look like a rectangle here. Okay. And here I have a prism, the development of which is shown here when we open it out and lay on a flat plane. That is called development. Now, the principle of development. Every line on the development should show the true length of the corresponding edge on the surface of the solid when it is being developed. So, you can assure that all the edges are having, or all the lines which represents the edges will have true length in the development. Now we will discuss about the methods of development. There are four categories. First one is called parallel line development for developing the prisms and cylinders. Second one is radial line development for developing pyramids and cones. Third one is triangulation development for developing transition pieces. And fourth one is called approximate development for developing spheres. In this video lecture, we only discuss the first two category. One is called parallel line development and the second one radial line development. Okay, development of a cylinder. Now draw the development of complete surface of a cylinder. Diameter is given as 40 mm and the height is 70 mm. Here you note that the development of the complete surface is given, complete surface of the cylinder. So that should include the lateral surface as well as the top and bottom faces, which is having a circular shape. So on developing the lateral surface of the cylinder, we can see that you will get a rectangle. Okay, on opening the lateral surface, you will get a rectangle. The length which will be equal to the circumference of the circle, okay, which will be equal to 2 pi multiplied by the radius of the circle, and the height or the width of this particular rectangle will be equal to the height of the cylinder. Okay, so you get the lateral surface like this. It will be a rectangle with the width which is equal to the height of the cylinder and the length which is equal to the length 2 pi r. Okay, 2 pi multiplied by the radius of the circle. So first we will draw the XY line. Now you will draw the characteristic view, which is the simple position within the top view here, which is having a shape of circle, and now you will draw the corresponding front view. Okay. Now the simple position is over, from which you have parallel lines like this. Now you will draw the first or the starting point, starting edge of this particular development. So you should get a rectangle. The first edge I have drawn here. Now you can take a length which is equal to pi d or 2 pi into r, which is equal to, in this case, 148.56 millimeter. So you can draw the rectangle. So that is the development of the lateral surface of that cylinder. Now you can draw a circle on the top and one circle at the bottom. That will make this development complete. So next we have a development of a prism. Develop the complete surface of the square prism of a side base 40 mm and height 80 mm. So you can see that the complete surface of a square prism. That means that you need to develop the lateral surface as well as the top and bottom surfaces. So the naming should be given like, if you are giving A, B, C, D, small letters are used for representing the top view, and A dash, B dash, C dash, D dash will be representing the front view. But in development, we will use capital letters to represent the corresponding points of the solid. So you can say that see that the rectangular shape will be there for the lateral surface similar to the cylinder, and the length of which will be equal to 40 times 4 times 40. You can see that A to B is actually 40 mm, B to C is 40 mm, C to D is 40 mm, and D to A is 40 mm. So this will be equal to 4 into 40 mm, and height which will be remaining as 80 mm, which is the height of the prism. So while you name, you can see that A, B, C, D, A. So this point is actually B, and this point is actually A. Okay. So this will go here, this will go here while you complete the solid. And here also if I name A, this is B, this is C, this is D, and this is A, and this portion will be A. So these two points will be joined together when you convert that into a solid, and this should be B. So this is how you develop, and you can see that only the boundary is represented with thick lines. You won't show this one. This will remain as a construction line. Okay, this is the development, the complete development of the surfaces of a square prism. Now we will see the development of a pyramid, which is something different from that of a prism or a cylinder. Draw the development of lateral surface of a square pyramid of side of base is 30 mm and height 50 mm. Resting with its base on HP, all the edges of the base are equally inclined to VP. So you can see that development of the lateral surface of a square pyramid. Okay, so it says that all the base edges are equally inclined to VP. So you can see the simple position will be like this. We call it as a corner condition, where all the base edges are equally inclined at 45-degree inclined to the vertical plane. Vertical plane is represented as the XY line. So next we have the corresponding front view. Okay, you can see that here the front view is drawn. Now here you can see that here the O dash A dash line represents the true length of the flange edge. How do you know that it's a true length? Okay, from the projection of lines we have seen that if one view of the projection of line is parallel to XY line, the other view, the corresponding other view will have true length. So here you can see that OA is parallel to XY line. Okay, OA is parallel to XY line. The corresponding front view, which is O dash A dash, will be having true length. The similar condition is there with O dash C dash and OC. OC is parallel to XY line, so O dash C dash will be having true length. Now I'll draw the parallel line and I will construct the first slant edge here with the true length and possibly parallel to this true length slant edge. So you can see that OA I have marked. Okay, OA I have marked, which is parallel to this true length slant edge, and taking O as the center and OA as the radius. OA is actually the true length of the slant edge. O as the center and OA as the radius. I will draw an arc here, an arbitrary arc, and now I will mark B, C, D, A at a distance 30 mm from the corresponding point. So I'll mark B at a distance 30 mm from A. So I'll mark B here, taking a 30 mm in a compass, and from A I'll mark B on this arc. Similarly, I'll get C, D, and again A. The A should be there because when you start from A, it should end at A itself. So I'll join this to get the complete development. So you can see that I have drawn the outer boundary as thick line, and OD, OC, OB are construction lines which are drawn thin. Only the boundary should be drawn with a thick line. And it says that only the lateral surface of the square pyramid. If it was the complete surface, you should have drawn the base also. So it might come like this. Okay, but in this case it is not required because they have asked for only the lateral surface. So this is in the case of a pyramid when we can get the true length of the slant edge, but there are other problems in which you may not get the true length of the slant edge. We will see in the next example. So here I have the development of a pyramid. Okay, again the development of the lateral surface, sorry, lateral surface lateral surface of a square pyramid of base 30 mm and height 50 mm, resting with its base on HP. Okay, it's at the simple position, and with the two of its base edges are equally parallel to VP. So we can see that the position is like this. We call it as edge condition. Here two edges are equally parallel to VP, CD and AB. I will draw the corresponding front view. So you can see that O dash A dash is not having true length because you can see that OA is not parallel to XY line. So O dash A dash will not be having true length. So true length of OA should be found out because in development we have all the lines with true length. So in order to get the true length, okay, here I have an edge OB which is not parallel to XY line. I will make OB parallel to XY line such that the corresponding front view will be having true length. So I will rotate OB with respect to with respect to O. I'll rotate OB. Now this line is parallel to XY line with the same length of the top view. Okay, I will get the corresponding front view which will have true length. So capital O, capital A, that line will be having true length of the slant edge. So I will draw the first line there. Now I will do the same procedure as that of the previous problem. I will draw an arc, an arbitrary arc with O as center and OA as the radius. Now I will mark B, C, D, A at distance 30 mm. Okay, so you can use a compass to mark B, C, D, A, and I will join the boundary. So this will be the development of the lateral surface. Okay, you can see that this is having true length. This is also having true length. Now we'll discuss the development of a cone. Draw the development of lateral surface of a cone of base diameter 50 mm and height 70 mm, resting with its base on HP. So it looks like this. We have the characteristic view of radius r. Okay, radius r, and let this be the corresponding front view. And I'll take the length of the generator as R, capital R. So this will be having true length because the corresponding top view will be parallel to XY line. So this generator is having true length. Now I'll draw the parallel line and draw the generator which is parallel to this one. Now I'll draw an arc here, an arbitrary arc. But I know that the length of this arc, okay, you can see that the length of this arc, which is L, we can say that it is equal to 2 pi r, because we are opening this circle actually. So the circumference is 2 pi r. The length of this arc should be equal to 2 pi r. And of course, this is capital R, which is the length of the generator, the true length of the generator. And you can't directly measure this length 2 pi r. You can directly measure, or you can, okay, of course, you can draw an arc here with length 2 pi r. It should be 2 pi r, but you can't draw the length as 2 pi r because you can't measure it directly using a scale. So instead, we have to find out the included angle, which is equal to theta. Okay, included angle theta. So in order to find the included angle, if you have a arc here, say the arc is having a length which is equal to, if this angle is theta and if the radius is capital R, the length will be equal to R into theta. R into theta, where theta is in radians. So from that you can find out what is theta. Okay, so theta is equal to L divided by capital R. So it's a capital letter L divided by R. So similarly here in this case you have L as equal to 2 pi r. So theta, I can write L as 2 pi r divided by r. This will be theta in radians. So if you want to convert that into degrees, you have to multiply that with 360 by 2 pi. So the final answer is theta is equal to 360 into small r, which is the radius of the base circle, divided by capital R, which is the length, true length of the generator of the cone. That will be in degrees. So if you know that in degrees, you can directly draw the arc. Okay, you can directly draw the arc. Okay, you can directly draw the arc. So I'll find out, okay, theta, which is equal to 360 into r by capital R, and I will draw another line which is having the same length as that of, okay, r. So this is also capital R. Now taking r as radius and this point as center, I will draw the arc. Now this represents the development of the lateral surface of the cone. Now we will see the development of a frustum of a cone. So you have a large cone here, out of which you are removing a small cone. That's called a frustum of a cone. So let R be the length of the generator of the large cone, and capital R1 be the generator of the small cone which is being removed. So we will see how it's being developed. Okay. So here I have the top view or the characteristic view of the frustum of cone. I will draw, okay, let this be the R be the base circle radius. Now we have extended the frustum of cone so that I can find out the point O dash or the apex. Now this will be the length which is equal to capital R, and this will be the length which is equal to capital R1. Okay. So now that's marked as capital R. Now I'll draw the parallel lines. Now I'll draw the first generator here of the large cone, and I'll find out the included angle theta using small r and capital R. You know how to calculate it. Now with that angle theta, I will draw the development of the large cone. Okay, that will look like this. Now I have to find out the development of the smaller cone, so that the difference will be the development of frustum of cone. So I'll draw the development of the smaller cone. Okay, you need not to find out the theta angle again, because it will be the same. Only difference is the radius will be r1. Only that will be the difference. Now this portion represents the frustum of a cone. With this, we come to the end of lecture number 1. I would like to thank Professor A. Gopalakrishna Pillai, retired professor of Department of Mechanical Engineering, RSET, as well as James Matthew, assistant professor of Mechanical Engineering Department in RSET. Thank you. We'll see you in the next lecture.